What's up guys, today we're going to learn how to design a complex cam with a simple harmonic motion which has the following wave design: 2 up, 1 down, 1 up, 2 down. And by the end of this video you're going to learn everything you need to know about cam design. So in our question, the wave design that is given is 2 up, 1 down, 1 up, 2 down. The minimum distance between the cam center and the follower center is given 2 units, and the lift of the cam is given 3 units. The follower diameter is given 0.5 units, and dwell period is given 1/3 into peaking time. And the motion our cam is going to follow is simple harmonic motion. So let's first do the calculations. Since this is a complex cam, there will be 4 dwells and 4 rise and fall sections each. Compared to the simple cams, we had just 2 dwells and 2 rise and fall sections. So let's proceed with the calculations. So by the time our auxiliary shaft will rotate 360 degrees, the picks that will be inserted is 2 plus 1, 3 plus 1, 4 plus 2, 6. 6 picks will be inserted as our tappet shaft or auxiliary shaft rotates 360 degrees. Okay. So that means time available for one pick is 360 divided by 6. So let's write that down. So this gives us 60 degrees. That's the time available for one pick. Okay, so let's find out the short dwell of this cam. Okay, so the short dwell is 1/3 into the picking time, which is 20 degrees. Now let's find out all the dwell times. So now for 2 up, we're going to have up dwell 1, which will correspond to 2 picks. So let's write that down. Up dwell 1. Up dwell 1. So up dwell 1 is time for one pick plus short dwell. And that gives us 60 plus 20, 80 degrees. I have added this because by this time 2 picks get inserted. That's why I have added time for one pick plus a short dwell. Okay, so now let's find out the first down dwell or down dwell 1. At this moment, I just need enough dwell time for one pick to be inserted. So we're going to include the time for short dwell only. Okay, so up dwell 1 is 80, down dwell 1 is 20. Now again, for up dwell 2, we have 1 up. So for this dwell, we just need the short dwell, since only one pick is being inserted. Okay, so now let's move on to our last part of the repeat, which is 2 down. It will be similar to our first dwell, up dwell 1. Again, because 2 picks are being inserted at this time. 60 plus 20. 60 is time for one pick plus short dwell here is 20, so we're going to add them. So we get 80 degrees. Extremely sorry, I meant this as down dwell 2. Okay, down dwell 2. So we have up dwell 1, down dwell 1, up dwell 2, down dwell 2. So that takes up 80 plus 20, 100 plus 20, 120 plus 80, 200 degrees. So for rise and fall, how much do we have left? So for rise and fall, we have 360 minus 200. Okay, so for rise and fall, we have 360 degree minus 200. As I said earlier in this video that there will be 4 rise and fall sections as well as 4 dwells. So that means for each rise and fall section, we're going to have to divide this number by 4. So that's 160 divided by 4, which is what? 40 degrees. Okay, so rise and fall is 40 degrees. So now let's construct the motion path. Okay, so we're going to have our first rise, which is 40 degrees. And remember this, the profile it will follow is simple harmonic motion. So we get a sinusoidal curve. So that's our first rise, which is 40 degrees. Then our updwell 1, which is a straight line since it's dwell, for 80 degrees. Okay, so now we're going to fall again, which is what, 40 degrees. And then we're going to have our downdwell 1, which is just 20 degrees, as you can see here. Then we're going to rise again for 40 degrees, and then we're going to updwell for just 20 degrees. As you can see here, our second updwell is just 20 degrees. So after that, again, we're going to fall to our downdwell 2, which is 80 degrees. So as you can see here, this is our first rise, first fall, second rise, second fall, updwell 1, downdwell 1, updwell 2, downdwell 2. So that's our motion path for this simple harmonic motion. So now let's start designing the cam. So to design this cam, we're going to need a protractor, a compass, a pencil, and a ruler. Okay, so now let's start. So we can see the minimum distance between the cam center and the follower center is 2 units. So we're going to start by drawing a circle which has a radius of 2 units. The first circle will always be equal to the minimum distance between the cam center and the follower center. Okay, so that's our first circle. Now let's see what else is given in the question. So also it's given that the lift of the cam is 3 units. So now we're going to draw another circle which has the radius of 2 plus 3, or in other words, d plus l, which is 5. So let's draw that. Okay, so we're going to get 2 concentric circles. Nice. Okay, so now let's start constructing the cam. So I'm going to divide this circle the same way our motion path has been divided for each rise and fall and dwell sections. So we can start with the first rise, which is 40 degrees. So we're going to mark 40 degree in our circle. Okay, so that's the first rise. Okay, after that, so now we're going to take 80 degrees, which is responsible for our updwell 1. So 40 plus 80 is 120. So that's 40 degree, that's 80 degree. And then we're going to fall again, which is another 40 degrees, which is all the way over here. So that's our first fall. And after that, we have another dwell, which is our downdwell 1. And downdwell 1 was 20 degrees. So we take 20 degrees over here. This is our downdwell 1. So after that, we're going to have a rise. And after that, we're going to have our second updwell, which is just 20 degrees. So 40 plus 20 is 60. That is our second updwell. And now after this, we're going to have our fall, which is 40 degrees. So 60 plus 40 is 100. There is our next 40 degrees. And then we're going to have our downdwell 2, which is 80 degrees. So we have successfully divided our circles into rise and fall and dwell sections. So just like any cam design, we're going to have to divide the rise and fall sections into a certain number of segments. Okay, so since our rise and fall is 40 degrees, we can divide them into 4 sections where each segment or section will have 10 degrees. You can also divide them into 8 sections for a better profiling, but 4 sections are enough. In that case, where you divide 40 degree by 8 sections, you're going to have 5 degrees in each section. But for the sake of simplicity, we're going to divide this by 4 segments. So let's bring out our protractor and divide our first rise section. Let me change the color of that. Okay. So since we're dividing this into 4 sections, each section will have 10 degrees. This is our first 10 degrees. This is our second 10 degrees. And this is our third and fourth 10 degrees. So you can see it's being divided into 4 sections. We're going to do that for the first fall as well. Then we're going to do the same for the second rise section. And lastly, we're going to divide the fall section again into 4 parts of 10 degrees each. So now for the displacement of our cam and follower center for a simple harmonic motion, we're going to have to construct a semicircle, as we know. So let's start by constructing the semicircle, and the semicircle will have the diameter of the lift. So diameter of the lift was 3 units. So the radius of the semicircle is going to be 1.5 units. Simply place your pencil on one of these rise and fall sections endpoint and bring the pencil to the edge of the first circle and draw a circle. Okay, so that's what it's going to look like. Now, as we have divided the rise and fall sections into 4 parts, we're going to have to divide this semicircle also into 4 parts, because this semicircle will give the displacement between the cam center and the follower center for each 10 degrees. So it's important to divide this semicircle into the same equal parts as our rise and fall sections. So since the circle has 360 degrees, a semicircle will have 180 degrees, right? So if we divide 180 degrees by 4, we get 45 degrees. So the sections will be 45 degrees each. That's our first section. Next section for the next 45 degrees. And then another 45 degrees. So we have divided our circle into 4 equal segments. So now we have to draw perpendiculars from each section. Since the middle section is already perpendicular, we don't have to draw a perpendicular. Let's say if you had divided the rise and fall sections into 8 sections, you also would have to divided this semicircle into 8 sections. So I hope that's clear. Now let's get to the main part. Now we place the compass in the first perpendicular that we have drawn from the segments of the circle. And here's where many people confuse it, but after today, I don't think you'll be confused anymore. So these are our sections, right? These are our rise and fall sections. So think of producing a insect head. Something that looks like this. Something that looks like this. It looks like the head of an insect, right? These are the antennas, this is the body. So think of producing the head of an insect. So if we have to produce a shape like this, then if we have to take the largest arc and place it at this point, as you can see, right? So let's draw this arc over here. So our first arc. Similarly, for this side as well, you see the largest part is over here. So we draw an arc over here. As you can see, the insect head will go like this and then like this, as you can see in this diagram I've drawn over here. So this is one way of remembering it. Okay, so that means the most farthest point will be this point over here. So we draw the largest arc over here and over here. Next, we'd go to the next perpendicular, which is over here, and draw a line on the next line to produce our head of the insect. We've already done these, so let's move to the next one. Okay, so over here we're going to draw the arc for every section. Okay, so now the next line, we go to the next perpendicular and draw the next arc across all 4 rise and fall sections. Okay, so we can kind of see our head of the insect is ready. Here are the antennas, here is the body. In the question, it's given that the follower diameter is 0.5 units. Now we have to represent the follower in this diagram as well. So in the question, it's given the follower diameter is 0.5 units. So I'm going to take a radius of 0.225 units from the ruler into my compass. And this is to represent how the follower will move with respect to my cam, and draw our followers. This is one follower. It's the movement that we're representing. As you can see, we're getting the insect head formation right now. So that is a good thing. If you don't get it, then maybe there's something wrong. You have misplaced arc or something. So please be careful about this. Okay, so that looks good enough to me. So let's construct the cam. We need to keep space for the movement of the follower during the dwell periods. So let's do that. Similarly on this side as well. And this side. And now we're just going to join the edges of this follower and cam profile. Drawing especially isn't one of my strengths, but if you draw in a piece of pen and paper, I hope you're going to get better results. So that is what the cam is going to look like for a complex weave of 2 up 1 down and 1 up 2 down. I hope you enjoyed this video.